Hello everyone. So my name is Hetav and today in this particular video we will be contributing to an open source library called Keras. And if you've never heard about Keras, let me just give you a brief introduction. It is a deep learning library made on top of three different backends. So you can switch between these three different backends in this library. The first one is TensorFlow, second is PyTorch, and the third one is something called JAX, which is a high performance array computing library. Now, in a nutshell, what Keras helps you to do is it gives you a lot of abstracted functions which make it easier for you to make your own neural networks or any kind of machine learning models that you might need and spans multiple different domains. You can make models for computer vision, natural language processing, etc. Now, without further ado, let's dive directly into this repository and we will be following a 13-step procedure to contribute to it. So first up, this is the Keras library, and as you can see, we have upwards of 10,000 commits, and the last one was made 36 minutes ago, so this does show that it's actually quite an active repository, and there are many people who wish to contribute to it. Now, the first step of our contribution is finding a project. Fortunately, we already have a project for this particular video. The next is read the contribution guidelines. So there are two files that we need to focus on. Number one is README. So let's go to the README. This is a brief introduction of Keras. Installation. Now this word can be misleading. You should not be looking at installation because usually it just refers to how a normal user would install that library. But as contributors, we actually want to tweak the source code and build it and test it out locally, which means that we should rather focus on something called local installation. So in the local installation, we have three steps. We have install the dependencies, run installation command from the root directory, and if you are changing some of the Keras exports public APIs, we need to run this particular script. We'll see. Based on the issue we are tackling, we may or may not have to use this command. Okay, so that is the README, but we should also look at some other file, which is called the contribution.md. So we pull that up over here. All right, so current items open for contributions. Okay, we'll check that out later. Open an issue. Again, we don't want to open an issue. We'll just pick an issue, make the code changes, create a pull request. Okay, once the change is ready, open a pull request from your branch. And it seems like there is no particular template for creating a pull request. They do have a CLA or a contributor license agreement, which we will need to fill out because Keras as a project is maintained by Google as of the moment, which means that there is a CLA by Google, which we need to fill out. The next step is code review. So your PR will be reviewed as usual. There are a few automated tests that will be running. Once a reviewer reviews it, there would be and approves it, there would be a ready to pull tag, which will be added, and someone from the team will merge it. Okay, so that gives us a pretty good overview of the process of how to contribute to it. The setup environment, again, we'll be focusing on setting up a local environment rather than a GitHub code space or dev container. And the commands for this are very similar to the commands we found on our README. So we'll skip this for now. For the code style, that uses black and ISOR to format the code, which is fine. Actually, when you submit a pull request, the automated workflows will check for your code format. So that's a good thing. And the last thing we need to focus on in the contributing.md is running the test. So there are a few test files and it says that we use PyTest to run the test. And we will be running some of the tests locally to make sure that we are not breaking something. There are different commands which we'll come back to when we are actually testing it. Okay, so we have read the README and the contribution.md files. That takes us to the third step, which is look for relevant issues. And in this particular video, I'll be taking you to one of the issues that I contributed to on Keras. So let me quickly get you over there. Okay, so this is the issue we will be focusing on today. Again, it says closed because I just submitted a PR which resolves this issue. But the issue, as per the original poster, is import Keras. You have keras.ops.once. We have a mask that is being created over here, and we have something called batch normalization that is taking place over here, where we supply the mask that we created, and we say training equals to true. And the title of this error is Error in Masked Patch Normalization with Greater than 3 Dimensions. Okay, so the title doesn't give out that much info. And fortunately, we do have some code to reproduce it. So this particular piece of code gives us an invalid argument error and an exception when this is run. And there has been some conversation that is taking place, and the comment that helped me the most was by this particular person. I think he's a maintainer or a reviewer because I see him quite often. So you should generally make sure that the mask only has one less dimension than the input. Example, in this case, mask is 1 to 1 instead of just 1 2. So what this particular comment means is that in the original code, the mask over here had 2 dimensions because the 1 comma 2, which you see in parentheses over here, indicate the dimensions. And the x variable had 4 dimensions. And as per the maintainer, the mask should be 1 dimension less. So because x is 4 dimension, your mask should be 3 dimensional, not 2 dimensional. And the reason why this issue was raised is that the error message over here was not descriptive enough to tell the user that the problem was in the dimension of your mask and the x variable that you just supplied. So in order to resolve this issue, the steps that the code changes that we need to do is to make this particular error message more descriptive and check for the dimensions of the mask and the x. If the mask has a dimension not equal to the dimension of x minus 1, then we should add this information in this exception message saying that, hey, the reason we actually raised this exception is because the dimensions are not as we had expected. So we have selected our issue. The next step remains forking and cloning the repository. So to fork the repository is the same step as usual. We go to the GitHub UI, we click on the arrow beside the fork option over here, and initially you would not have an existing fork over here. You'd have to create a new fork, but in my case, I already have a fork, so I can just go to that particular repository. And one important thing that you should always be careful of is in these kinds of projects, which are extremely active, it is very likely that your fork of the repository will be out of sync from the original project. So before you start making changes, click on the sync fork button and say update branch. As you can see, this branch is out of date, so we do need to sync it up. And the next thing we need to do is clone this repository. So we click on the arrow in the green code button, copy the HTTPS URL, and we go back to a location where we actually want to work. So let me just open the folder. So this is the folder where I like to work. And let me just open the git bash over here. Again, if you do not have git bash installed, there would be a link in the description explaining how you can install git bash no matter your operating system. And also just a shout out, if you're not familiar with these 13 steps that we have been following, I do have a video and a card should appear somewhere on top of this video to guide you over there. All right, so we have a terminal and the command that will be helping us today is git clone. So let me zoom in a bit. And the URL, as I said, copied from the Git UI, paste it over here. The cloning will take a bit of time. Okay, so the repository has been cloned and we can check it right over here. So we have the Keras repository. Let us get one step into this repository and we are on the master branch. If you refer to our guide or a 13-step process, the next thing is create a new branch. So to create a new branch, you can use the command git checkout -b. -b is just for creating a new branch. And over here, we need to add check for mask dimension. So we add a descriptive name for the branch and then switch to the branch. The next step is setting up a virtual environment. To do so, I'll be using the WSL, which is Windows Subsystem for Linux. And it is also recommended by the Keras team that you use a WSL if you're working on the Windows machine. If you're on Linux or Mac, it is fine. You can just use your normal terminals. Okay, so let me zoom in a bit. So we are near Keras. We need to create a new virtual environment. The command for that is Python, in my case, Python 3 minus m vn, and I'll just call my environment env. You can name it whatever you want. All right, so once the environment is created, we activate the environment, and the code for that in Linux is environment bin activate, and the keyword is source. The left-hand side shows that the environment is activated, and once we are done with creating a virtual environment, the next step is to make changes. Now, to make the changes, we do need to go back to our README file because the README has instructions on how to do a local installation. So the first step it says is you need to install all the dependency. So let us copy the code over there. We go into Keras because you always need to make sure that your requirements.txt or requirements common.txt is present before you run that particular code. Let me reduce screen size if I can so that the code comes in the screen. All right. So the code is pip install -r requirements.txt, and this will take some time. All right, so we're done with the installation procedure. And over here, you see some messages like requirements already satisfied. And that is because I already have installed the dependencies before, but you'll see slightly different messages. As long as you don't see errors, you should be in good hands. Once we are done with the installation of the dependency, the next step is to build these dependencies. And for that, we have the second command, which is python pip-build.py install. So we go back over here, and the place where you should run this command is within the Keras directory. However, there's a small change if you're using Linux and if you're using Python. So it is Python 3 instead of just Python. And we'll have pip-build.py. So pip build.py followed by install. This again will take some time. Okay, so now we have the installation and making all the dependencies successful, and you should see a message somewhat similar to this green line over here, successfully built, which means that we did the first two steps successfully. Once we are done with this, we have completed the installation part. Now the next step is to actually make the changes. And in this particular example, the change that we have to make is to identify the dimensions of the mask and the input tensor and make sure that the mask is one-dimensionally lower. So we now go on to our VS Code and we open the file that we really wish to change. Again, this is not a debugging tutorial, so I won't tell you how I came across this particular function. If you were to debug it, it's pretty simple. You just analyze the error stack, and you'll see that the call function was being called within the bash normalization, and it does have a mask, and the self includes the variable or the object on which this call method is called. So again, this is not a tutorial on debugging or actually fixing an error. So what I'm going to do is I'm going to go to the pull request that I created, and I'm going to copy the fix from there and paste it over here. So let me go to the pull request that I had created over here. Files changed. All right, so this is the code that I have added. So I go back over here and I paste it. And a quick run through, because it's not very hard to understand, is that if mask is not none, so if we have provided a mask value, we check if the length of the mask shape, which is the shape is an array of all the dimensions, and the length will give you the number of dimensions we have. If the length of the dimension of mask is not equal to the length of the dimension of the input -1, then we raise a value error saying that the mask provided should be one dimensional less than the input, and there's just some additional information that is useful for debugging. So quite a simple change. Once we're done with that, we want to check if it actually created a difference. So before we add this check, let me do one thing. Let me comment this off. And let us first try to reproduce the behavior which was seen in the issue over here. So the issue showed that we do have this argument received information, and we do have the exception encountered, but we don't have any other additional information. So let's see if that's true. I have created a test script over here, which is nothing but a copy paste of the sample code that had been provided in the issue. So I go back over here and let me just clear off my screen so that you have a clear view of what's happening. We have Python 3 test.py, which is one level above Keras. So we have Python 3 test.py. Let me just run that up. Okay, so now we can see that we do get an incompatible shape error over here, and we have arguments received. And this looks very similar to what was posted in the initial issue. So now all we want is an additional line giving us the information that, okay, it was actually a dimensional mismatch. So we go back to our VS Code, we uncomment the changes we made. However, when you uncomment the change you made, you also need to remember that you need to build your Keras again. So you need to now go to the Keras repository, local one, and then you have to run this pip build command. So once we have rebuilt the project, we can go on and test whether our code actually made a difference. So let me just clear it off, and I'll be using Python 3 to run the test file again. So in the new output now, we can see that we have an additional message over here, which is the mask provided should be one dimensional less than the inputs and received mask shape of 1, 2, input shape is 1, 2, 3, 4. All right, so it is working. Now, before we actually push and commit this change, we need to make sure that we test it out. And if you go to the contribution.md, there is a mechanism to test for your local files. For example, you run pytest and you look for a file name underscore test.py. In our case, batch normalization has a batch normalization underscore test.py. For the sake of time, I won't be running it because I've already run it while making this change and everything has passed. However, whenever you make your change, make sure that you do not forget this step to run your test files. It is very essential. Okay, so once we're done with that, we go back to a 13-step approach. We make the changes. We have tested our code. Make sure that you do test your code. And now we need to commit descriptively. So we go back to our Git terminal or our Git CLI. Let me zoom in a bit. Let me clear this up. Okay, so we are already on our branch. We can check the status. So we have made one change over here. We can do a git add dot works over here, but you should usually write the file name and make a descriptive commit saying added a check for mask dimensions in batch normalization. So once I made the commit, we can push this to our branch, which is add check for mask dimension. And once we push this particular commit, we should have it show on our GitHub profile. So I can go back to my profile and navigate to the fork of the Keras repository I was working with. And you should see that we have some recent changes pushed 23 seconds ago, and we can click on compare and pull request to open a pull request to merge it to the base repository. Again, I'm not going to do so because I've already pushed this change in the main repository. What I will do though is actually go back to my original pull request and show you how I structured it. So it says this PR or pull request fixes this particular issue. In our case, this is the number for the pull request, and by adding a more descriptive message to the mask mismatch exception in batch normalization. Now I add a snapshot of what the error message was before and what it is after this particular change. You can also highlight it for more clarity. And this repository, as I mentioned before, has a CLA. So make sure that you click on the failed invocation, because the first time you're actually contributing to this repository, you will fail the CLA check. So click on the failed invocation, sign the CLA. There will also be an option to refresh your PR. Make sure you don't forget that, because even after you've signed your CLA, you do need to refresh it. Otherwise, you won't pass this Google CLA check. Once it has been done, there'll be some reviewers, they'll be working on your code, they'll be asking you to make some changes. Make sure that you make those changes and commit it as per requirement. And that is the end of your contribution journey. Hopefully, once you've satisfied all the requirements, you will merge it up. And that is the end of the 13-step procedure that we have seen over here. So we push the changes, we open the pull request, we respond to the feedback, and at the end, we merge the contributions. So I hope you enjoyed this video. I hope it added some value in your journey of contribution to open source. As usual, if you like my videos, please like and subscribe, and I'll love to make such videos in the future. Thank you.